Okay, so this video is going to, again reinforce inheritance, and it's gonna go over a new concept called method overriding. Um, we went over method overloading, where you can have the same method names just with different. For instance, look at this is a constructor. It's a method. It has a bank account that doesn't have anything passed in, but this bank account is still a bank account constructor, but it has it passes this in. So this is method overloading, and at runtime the compiler will choose which one depending on what's being passed into the method from main. So there's this new concept called method overriding. Let's look at this. So we got a bank account, and a bank account knows about the bank account's balance. And you can throw in an initial balance. And so then you can deposit money. And when you deposit money, that will change the balance. And withdraw money, that will change the balance. And then you can get the balance, and then you can transfer money from a bank account, from your bank account to another bank account. And you'd have to, an amount of money would have to transfer. Okay. So then there's checking and savings accounts. Both are subclasses of the bank account class. And so the bank account is the superclass. And so in this case, now this isn't really how it works anymore, but the way it used to work as a checking account, you had a certain amount of free checks you could write each month. But if you went over that, then you'd have a transaction fee. So I'm just assuming that if you write a certain amount of checks, you have a fee. So in this case, when we inherit the, deposit and withdrawal methods, we can do something called overloading. And overloading, overriding. An overriding method would be you've got a checking account object and you call a deposit or withdrawal. It actually calls the deposit or withdrawal method inside the checking account class instead of the withdrawal or deposit method in the bank account class that's being inherited in. And I'll show you how that's going to look here in a second. The only difference is that each time you deposit or withdraw with your checking account, you will have to, add up this transaction count, and at the end of it, you'll have to reduce your, the number of fees. So, anyway, with a savings account, the only difference is the savings account has an interest rate that you can earn. So it has a method that adds interest. But it will be able to get the balance and deposit when withdraw from the bank account class. Now, notice over here, checking account has a deduct fees, but the get balance will be called that gets inherited in up here, okay? And, again, the only difference is overriding methods are going to look a little bit different from the checking account class to the bank account class. So let's get kind of started on this one. So we'll say this is going to be my bank account, all right? And so I'll say bank account, my bank account equals new bank account. And I'm going to have $55 in there. Actually, 55, yeah, that's fine. Okay. All right, so the bank account will initialize that and then put some money in there. So let's create a bank account class. Okay. So, and I like getting rid of a lot of this junk, so So we'll have a private double balance, and we'll have a public bank account. And this one will be balance is equal to 0 if we I didn't put two O's in there. Let's refractor this. Sorry, that's kind of gonna freak me out, so I fixed it. Okay. So then we'll have another constructor that will pass in an initial balance, and we'll say that the balance is equal to initial balance. Then we'll have a public void deposit that accepts an amount, and the balance is going to be equal to the balance plus amount. Or you could just say balance plus equals amount. Whichever way you want to do it, it doesn't really matter to me. It's not a big deal. Then we'll have a public void withdraw. And we'll also pass in the amount that you would like to withdraw. And you would say balance equals balance minus amount. Or okay. And then public double get balance, where we return the balance. And you can also transfer money, so we could say public void transfer. Whoops. We transfer an object called other. We transfer from an object called other. So watch this. So we'll say withdraw, because a transfer is really just a withdrawal from your account. So we'll draw the amount, withdraw the amount, and other will receive a deposit for that amount. Okay. So again, we have to pass in the object that you want to transfer to, and so what you'll do is you'll take from your account, and you could also say this right here. That's kind of the standard way. This class bank account will make a withdrawal from this bank account. It will withdraw it, and then the other will receive a deposit of the amount. Okay. So that's the bank account. So I could say my bank account dot deposit 100 and do a system dot out dot println. After the first deposit, my bank account has so after the first withdrawal, my bank account has, and then we get the balance. Okay, so we're going to get all this tested. Make sure everything works properly. Okay, so okay. And then the next up, we'll call this next one. I'm going to cut this out too. Call this one Jim's. So that's what we're going to create next. All right, so let's run through this. So we've got 55 bucks initially, so 55 should display. We add 100 to it, so it should be 155, and then we withdraw, and should be, what, 144. Okay, so let's run this. And I'm going to just put this stuff in here. Okay, initially my bank account's 55. After the first deposit, I got 155 because I added 100, and then I took out 10, so that's 145. Okay, so that looks good. So the whatever it's called, the bank account info looks good. So now let's do this. Let's say checking account, and we'll say Jim's checking account was new checking account, and we'll start him off with 100 bucks. Checking account. Okay, cool. So let's do this. So right click new, and we'll call it checking account. Okay, so we got a checking account, and we go back to the UML model. The checking account has to extend the bank account. It's got to inherit in some information. Okay. So we'll have private int transaction count, private static final int free transactions will be 3. And we'll have a private static final double transaction fee, and that'll be $2. So public checking account, and we'll do this one as our initial balance. So we'll say int initial balance, and we'll have to super the initial balance and transaction count be equal to 0. Okay, so again, right here, we super this in, and all we're doing is the initial balance is, the balance right there. So we can super that in. Now you need to make sure that super is the first word in this in order to do that. Okay, I'm not sure if I've mentioned that, but definitely got to do that. Okay, now we're going to override the methods here, so we'll say public void deposit, because we want the checking account to use this deposit method and not this deposit method, okay? And double the amount, and we'll say the transaction count is added up one time each time you deposit, so we'll say super dot deposit the amount. Okay, so then this deposit method gets called first if you're doing a checking account, and we add up the transaction. Then we call this deposit method, and then we run our, our deposit here, which passes in the amount, and then the balance gets added up. Okay. So withdrawals are going to look real similar. Transaction count will be added up, and we withdraw the amount this time. Okay. Now public void deduct fees is our last one, and so I'm pretty sure that's the last one here. So deduct fees. So we'll say if transaction count is greater than free transactions, then we'll have just a double fees is equal to the transaction fee times the transaction count minus the free Okay, so after we call deductions, now the deduction fee would be called like once a month at the end of the month. So you'd add up all your deposits and withdrawals that you did, which would add up this transaction count variable. If that's greater than 3, if you wrote more than 3 checks or whatever, or deposited more than 3 times in your checking account, then you would take your transaction fee of $2 and times it by, so if this was 10 minus 3 would give us 7. 7 times 2 is $14. $14 of fees get withdrawn from your account. Okay? So we can go back in here and start testing this. So I'm going to copy some of this stuff because it just gets to be kind of redundant. Initially, I would say initially Jim's checking account. Initially Jim's checking account has, and this would be Jim's checking account dot get balance. So then we can do Jim's checking account dot withdraw 50. We can say after the first withdraw, Jim's checking after first withdraw, well, I guess it'd be withdrawal. Jim's checking account has, and then it would be Jim's checking account dot get balance. Okay. After the first, get balance. Okay. All right. So so he has 100. We withdrew 50, so he's got 50. We deposited 10, so he's got 60. Okay, cool. That looks good. All right. All right, we're going to call the next one Mom's Savings account. Call this one Savings. Okay, so we got to do, let's look at this real quick. Let me just, so savings account just has an interest rate. And, okay, cool. Okay, so, whoops, I didn't do, yeah, that doesn't matter. So savings account. Okay, so that's also going to extend the bank account. Okay, and then we'll have a private double interest rate. Then we'll say public savings account gets passed in the rate. And this is going to know how to add interest. All right, so get balance gets supered in, or inherited in, not supered in, but it gets inherited in from the bank account. Okay, so we can get the balance, and we can deposit the money into the interest, the interest on it into the deposit method. Okay. And you know what, I screwed up here. Her interest rate's going to be 0.05. Okay. So then we'll say mom's savings account dot deposit, and so we'll deposit some money in, and mom's loaded, so we're going to give mom 10,000 bucks. Okay. We'll do system.out.println. You know, after the first deposit, my mom's savings account has now mom's, I got too many S's. Mom's savings account dot, and we're going to transfer money from mom's account to Jim's checking account. And we're going to give Jim 2,000 bucks. Okay. So we got to test this now. We got to get the balance from Jim's and mom's account. So after the first transfer, my mom's savings account has and then mom's savings account dot get balance, and then okay. By the way, we do, let's count Harry's transactions, because he's got Jim's checking account has 2 transactions. So just make a quick side note, Jim's third checking account transaction. Okay, and we're going to do this again because I want to do transactions. So we'll do, instead this time we'll do, so that will be Jim's fourth checking account. Okay. Okay. So now what we'll do, we'll test this real quick. Let's look at this. So my mom ended up having an interest rate of 0.5. So we haven't added interest yet. So she had 10,000 minus 2,000. Okay, so she should have. Let's see what I got here. I might have an error. So we tested the first two; those are all right. Initially, mom has $0. Then we deposit 10,000. After the first transfer, we transfer 2,000 out, so that's a withdrawal, and we added that into Jim's account. So he had 60. Now he has $2,060. After the second transfer, my mom has 7,000. Okay, so that looks good. That looks real good right here. And then last thing we got to do, we got to test our add interest. And so this is going to simulate end of month transactions. So we'll just add the interest in. So mom's savings account dot add interest. So after the end of the month transaction, my mom's savings account has and then we'll do a plus. Oh no, we already did that. Mom's savings account dot get balance. And then we'll do a Jim's checking account dot deduct fees. So so after the end of the month transaction, deduction, Jim's checking account has all right, let's run this. We're gonna have to do some math here. Okay, so we knew these were all right. These were okay. And then we went down here and we knew that those were okay. So after the end of the month transaction, my mom's savings account has $735. So let's go back to this math real quick. And I did passed in 0.05 or 0.5, I think. Let's see what I passed in. Yeah, 0.5, okay. So the math behind that is what? 0.5 divided by 100. So that's my rate. And I multiply that by, I end with 7,000 with my mom. So I go times 7 is $35. Okay, but then I deposit that in to whatever she had, right? And so then I've got to basically add in the 7,000. And so there you go. That's looks good. So there's that. Now, Jim had $60, and we gave him 4 transactions. So if we get into the checking account, he gets 3 for free, right? So 4 minus 3 is 1. So 1 times the fee is $2. So if he had 3060 minus $2, he ends with 3,058. Okay. So again, let's kind of recap. The main purpose of this was to demonstrate inheritance, but also introduce this idea of overriding methods where, at runtime, a checking account would call this deposit as opposed to this deposit method. And it's fine if I super.deposit and call this one if this has code that I want to use, but I also want to make sure that it's customized to the checking deposit or checking account class as opposed to just calling the bank account class. So it's smart enough to know which deposit method to go to. Now savings, we just use the bank account deposit for the savings account class. So anyway, this video is done. Make sure you're typing this out and understanding what you're doing. Make sure you're able to read off these UML models because you're going to be programming from them in some of our labs coming up. So anyway, this video is done.